Welcome back, happy fabricators, to another episode of Fab Tool Friday, where I bring you a tool that you've either seen in this shop or I've found useful in the fabrication industry. My name's Alex. Let's get started. Okay, so the tool that made the cut for this episode of Fab Tool Friday is the Vevor mag drill. So Vevor is a Chinese company that makes an assortment of tools and other accessories, and I've found them in general to have decent quality for the price point that you get them. I bought multiple other Vevor things with my own money, like the chain hoists for our jib crane build, the hydraulic jack for our swag off-road press brake, and multiple other things around the shop. So when Vevor reached out to me and asked me if I wanted to give their mag drill a test run, I decided I'd give it a go. Now, normally when I do a Fab Tool Friday, I bring you a tool that I've used frequently and have some background and experience with. Now, I do have background and experience with mag drills in general, but I have not specifically used this one. So this is gonna be kind of an out-of-the-box first impressions, and you'll get my firsthand thoughts on it. I have no obligation to say that I like this thing or that I don't like this thing. So let's dig into this thing together. Okay, so out of the box, these are the components that this specific model comes with. We've got a coolant reservoir, so this thing is coolant compatible and allows you to run coolant through the tooling down to your cutting surface. We have a 3-jaw chuck or a Jacobs style chuck. This one is definitely not up to the quality standard of a Jacobs chuck, but we'll have more on this later. We've got a centering pin and an assortment of 3, 6, 9, 10, 11, it looks like, different sizes of annular cutters, ranging from 12 millimeter up to 27 millimeter. Now, if you're not familiar with an annular cutter, basically the difference is a standard drill bit traditionally has 2 cutting surfaces, and what happens is when those cutting surfaces are fighting for surface area or surface tension, you often get a triangulated or an oblong hole as this thing is cutting down. Whereas with an annular cutter, you have usually 4 to 6 cutting surfaces that are on the outside of the bore diameter. So in the end, what that translates to is less chatter in the bit and a more precision round hole. First off, this mag drill has a Weldon style collet, which is a good thing right off the bat. A lot of other mag drills have Weldon style annular cutters, so it's going to be super versatile, and you should be able to get tooling for this thing fairly easily. Now, if you're not familiar with the concept of a mag drill, basically what this is a portable drill press. So you are able to pick this thing up, which actually another thing I like about this is it's not super heavy. A lot of mag drills are super heavy, and this one is not. But back to the portable part, you're able to maneuver this thing on a metal or ferrous surface, and it has an electromagnet in the base that you can turn on and then lock down. So as you can see here, I'm on my weld table on wheels, and I can, with the magnet on, I can pull this thing around, or if I turn the magnet off, I grab it and tip it over. It also allows you to drill in different orientations. So I can lay this thing on the side of the bench, turn it on, let go of it, and it's gonna stay right there, hang on to it, turn it off, and it's gonna fall on me. And depending on your situation, you can even do it upside down. A lot of times you recommend tying it off, especially if it's hanging off of something, so it doesn't fall if you accidentally bump that magnet off when it's upside down. But it is very possible to drill holes upside down with this thing. I've done it before. Okay, so squareness is one of the primary reasons for a mag drill. We're gonna do a little test with our Fireball square and line this up with the collet body on this thing. Okay, so with our collet body lined up to the square, we have the tiniest bit of gap in here. We got our feeler gauges out, and I can slide a 2.5 thousandth feeler in there, but a 5 thou won't go in there. So we're right in between 2.5 to 5 thousandths of deflection on the collet body. Okay, so the next thing we want to test for accuracy is deflection in the ways. So how rigid this setup is. So what that means is this carriage that the drill motor rides on what is called ways. So they're basically a sliding track. And if there's any deflection in those ways, that is going to take away from the accuracy and the squareness of drilling our hole. So we want to see how rigid and quality these ways are. Okay, so what I've done is I have lined up my dial indicator on the casting on the front of the motor head, which is directly connected to the ways. So this is one piece, so there shouldn't be any deflection that isn't translated directly from the ways itself. So if we watch our indicator, I'm going to grab a hold of the top of this and pull into the table. We've got about 5,000 deflection pulling. Now we're going to push it, and we've got about 3 thousandths to 4 thousandths of deflection pushing it. Now that's not too bad. I'm not very disappointed with that, especially since the distance that that lash is carried out across is only about 3.5 inches that makes contact on those ways. Grabbing on the top of it like this, moving it that way, and then pushing it that way, we only got about 5 thousandths of deflection. Next thing we're going to check is the overall throw. So this thing comes down to 0, where the collet can hit the table from the bottom of the magnet, and then it's all the way up position. Looks like we have about 4 7/8 of an inch of a vertical throat depth on this thing. Now let's get some tooling in here and see how it drills. Now, like I said, this is the Weldon style collet. So basically it is a 3/4 inch shaft with 2 flat spots on it. They're going to correlate with 2 set screws on the machine itself. So just make sure those flat spots line up with your set screws and crank those down. This one also comes with a center pin for the annular cutters, and that pin is spring loaded, and that's going to help you align with a dimple or a center finder for getting your hole all lined up properly. So now that we got our 16mm annular cutter all loaded up, we're going to try this out on my DIY table saw fixture table, and we're going to drill a couple more clamp holes. So what this is are these are fixture clamps that can drop down into a 16mm hole. And once they're in, they will side load themselves, and then you can hold your material down. If you want to see how we built out this table, I'll leave a link down in the description below. So what this mag drill allows us to do is we have our center here, and then we can drop this down and maneuver the unit itself until our center finder pin is in the dimple that we just made. Now you can see it collapsing there. We can turn our magnet on. Now the unit is locked in place. Instead of using coolant, I'm just going to use a little bit of anchor lube with some cutting paste. Wow, that was real-time speed. We will turn our magnet off, move this over and clean it up. So this cast steel or cast iron, whatever it is about 3/8 of an inch thick, and that just sailed through it. So that is pretty cool. And that's not a small hole. That's 16mm or roughly 3/4 of an inch. And we've got up to 27 mils, and you can buy even larger bits or annular cutters to do that. Okay, so now that we've tried out the annular cutter, let's give the 3-jaw chuck a try. Now this is the part that immediately out of the box I'm kind of skeptical of. The rest of this thing in general feels pretty robust. The castings on it are actually really nice. Machine surfaces appear to be really clean and machined well, but this 3-jaw chuck seems to be the opposite of all those things. Just touching it feels kind of jank. So we shall see. Okay, so actually the first thing that I noticed is kind of a problem here is with this 3-jaw chuck on, this is all the way up, and I don't know about the drill bits that you use, but most of my drill bits are longer than 2 inches long. So that's going to be a downside. Immediately, if you're going to use the 3-jaw chuck, you're going to have to get a piece of tubing or something like that that's tall to mount this thing up higher on and get it above whatever you're working on. Okay, so I kind of jankified it up on top of some fireball squares here just so that we could get some distance to get an actual drill bit in. But before we do that, I'm going to stick the dial indicator just on the chuck itself. So now let's check and see how accurate it is. See how much runout it's got. Now to give it the best chance possible, I'm going to use a brand new drill bit. And the reason I'm going to grab this style of drill bit is because it has 3 flat spots on it. So it should seat perfectly on each of the jaws and have the best chance of being the straightest and having the least amount of runout. Okay, so with the indicator pretty much zeroed out there, let's turn this thing around. And oh wow, we've got 20 thou that direction and another 10 the other direction. So we've got over 30 thousandths of runout right at the end. Now, based off of just holding that chuck in my hand, I can't say I'm too surprised. So far, this has been pretty good, but that chuck is very much leaving something to be desired. Another thing I want to check is measure how loud this thing is, just because it sounds pretty loud running this thing. So let's give it a quick go. Huh, it's actually quieter than I thought it was. We looked like we were about running 95 decibels at 3 feet away-ish. So must just be the tone. I thought it was louder than that. Not too bad. Now, as I briefly mentioned earlier, another feature this thing has is being able to run coolant through the cutters itself. So if we flip it around, we have a hose fitting there, and you can mount your coolant reservoir to the side of this guy and a quick little press fit. And then it has a little regulator to regulate the amount of coolant that you want going down into your tooling. I'm not going to do that today because I don't want to make a mess on my bench. So I'm going to leave that for you to wonder if it works properly or not. Another thing that I noticed though, something that is pretty important to me that this is lacking, is if you notice there is no speed or RPM adjustment or regulation here. So this thing is set at a fixed speed, and I believe looking at the instruction manual, I believe it said it was 810 RPMs, which I feel like is a little fast for especially some of your larger cutters. I think I'd prefer to be down in the 600 range, or at least be able to dial that in to what seemed right for the individual job. So I'm going to give it a on that, but looking into it, I did see that they do have other models that do have variable speed, but they are about $100 more. So this specific model comes in at about $250, and the ones with the variable speed were like $350. So they do have them, but I feel like that all mag drills should have a variable speed. Okay, so the final specification that I want to look at on this specific unit is the throat depth. And what that is the depth from the center of your collet to the face of the drill itself. So in this case, if I go from there to the center of the collet, we are at 1 1/8 of an inch, so 1.125 inches. So if we double that for the size of the saw or the cutter, that means that if you leave a little bit of room, the max hole size you're going to be able to drill is 2 inches with this particular drill, and that would give you 1/8 of an inch of gap between the drill and your cutter. That's not the best. It would be awesome if it had just a little better throat depth, especially for the fact if you wanted to slide a piece of tubing in there and drill some holes in your tubing, that doesn't allow you to reach that far over a piece of tubing or something like that. So that's definitely a downside to it. But my overall summary with this thing would be, I would say for a budget application, it's not too bad. The ways are very rigid, I believe, for the price point. The castings and everything on it seems fairly robust for the most part. The cordage and the castings all look really clean. The ways feel smooth. There's an acceptable amount of slop in the rack and pinion. There's the tiniest bit, but same amount in every other mag drill that I've used. My biggest complaint is the 3-jaw chuck that it comes with. It's junk. So if you decide to get this machine and you want to use the 3-jaw chuck, I would highly recommend upgrading that thing. But besides that, it's not too bad. So thanks for sticking around this long in the video. If you want to see more fabrication content, click some of the links that are going to pop up here. If you want to be notified of upcoming videos, hit that subscribe button and ring the bell. It's free to do so. And go build something, guys. I drilled a hole upside down.